Hi, my name is Nathan Kress. I am a graduate student at the University of Oklahoma. This is our IMDB ratings prediction system using data mining and machine learning techniques. In this presentation, we'll start with an introduction and we'll go through related work, and then proposed work and results, then conclusions and future work, and a demo of our application. Film and TV shows cost upwards of at least millions of dollars to produce and make. Then at that point you have a multi-million-dollar investment which can take up to years to develop and shoot and edit and have a final product. And then once you have a final product, you have to do audience testing where they rate what they liked about it or didn't like about it. And that's really after that initial investment's already been spent. So our task was to create an IMDb ratings prediction system based on the entire history of film and TV from a data dump we have provided by IMDb. Some related work to ours that we used in ours, predicting social media with predicting the future with social media, data mining approach to analysis and prediction of movie ratings, a predictor for movie success, predicting IMDb movie ratings using social media, and a number of others. So, our proposed work and results, we developed a web application that utilizes data mining and machine learning techniques to build a potential cast and crew of a new project. So you can basically do some forecasting analysis with it, at least of what the rating would be, and generate a predicted IMDb rating score through regression. We also provided a class label with classification, where we basically rank and give a class label to each proposed title, anomaly detection in the data, and clustering. We used R and Python for those tasks. So as I said, our data is from IMDb's entire catalog of film and TV shows up to around the end of August of 2018. We loaded it into MySQL databases so we could test our results on films released between that time. There was actually over 52 million records being used by our app. The web part was written in PHP using Sublime Text Editor, and MySQL using a WAMP server. Regression was written in PHP and MySQL. Classification and clustering were done in Python. Anomaly detection in R. Our future work, we would want to continue to fine-tune each part with the data and get more accurate results. We'd make more prediction with future titles and then fine-tune each area further so we can make more accurate predictions. And further narrow the weights on regression based on correlations found between time and amount of accuracy and weighting more and less toward the contribution of each position. Say if it was found that the cast has a little more weight than the director and writer, would basically apply and fine-tune those weights more based on the results that we receive. We could also narrow the results drawn in history of cast and crew, apply our higher weights to applicable history. So for example, someone has a history of comedic titles and they move into a drama. We'd want to take that into account and give them a higher weight in comedy than drama, basically. We were effectively able to apply a regression score and to potential titles, and were able to predict ratings with a fairly high degree of accuracy, especially considering the raw data scores we got back in September were actually rounded 9.5 and above, became 10, etc. So you're going to have a little margin of error there. And we basically contacted them about getting additional columns, and they said they would provide those scores and additional data if we wanted to for a fee in the future. There does appear to be a correlation between highly sought after cast crew and the final score predicted in regression, more so than just the genres themselves. So further testing would be needed to know on lesser known titles to apply this formula in the weights. Movie rating averages of all genres actually have been going up in the last decade, which is something we noted. And specifically in clustering, the top 250 rated movies were clustered in 3 groups. Elements in one cluster were more similar to that than other clusters, and the cluster result could further be improved by involving more features like actors and budget. But as I said, one, it'll give a dimensionality problem, which requires dimension reduction techniques, and 2, it was sort of out of the scope of our project for this class. We could purchase that in the future if we chose to do so. Classification, we divided results into 4 classes: excellent, average, poor, or terrible. So you basically get a score on your proposed title. And we use number of votes, genres, runtime, minutes, movies, year as features for classification, and the K-means gave about 65% accuracy with K equal to 11. So, how to use our prediction rating system. Now, you'd say, so we take this title, Venom, for example. It got exactly a 7.0 rating on IMDB, and let's see, 335,000 votes it looks like. You look up the cast and crew, you get their ID number out of the URL. So you take the lead cast, the director, and the writer. They each have an ID associated with their page and their work, basically. So you take that ID and a title and the specified genre, and we're using this as a test result because this movie didn't come out yet up to the point of our data, and this is now about 4 months later. And so basically we use it to predict one that came out in the last few months, and this one we actually got right with regression. So you take all those IDs, input, we'll do a live demo here in a minute, and you get a predicted score. Ours was 7.0897. And there's actually a number you get. So here's the title, here's the genre analysis of that action sci-fi. That's what the average rating you're going to get with an action sci-fi, average number of votes, total number of votes. This is all time, so all of IMDb's history, and then in the last year. And the cast and crew all time, and then in the last year. And you're going to get the mode and the means for those. And you'll get a predicted score for the genre itself, a predicted score for the cast and crew, and then a predicted score of your title overall. In this case, we actually got a hit. We got, I think, 3 hits on this test data. So the title doesn't really matter here. It was just, you could put in whatever film you want and then future cast it is kind of the point, but this is just a test result. So if you want to see what someone individually contributes, you can just add and remove people. You can use one or more basically from the director on. Regression's taking all the history, like I said, and then all the history in the last year, and we're getting averages of all those and coming up with a predicted score. This was some of the regression random sample test results of high-profile movies in 2018 released. It actually got a 95.5% accuracy on the rate of predictions for those. Now, you'll notice the ones highlighted were correct predictions between what was actually the score actually received to that. The ones highlighted in blue were Oscar contending films, which typically are going to be rated a good amount higher than normal films. And then we have some that were highest deviance, but those films seem to have bad reviews, considered flop. We looked at the financial data for those, and it was consistent that it didn't do well, basically. So then when you scroll down there, you get links for other tasks. So let me just go straight back into that and get it off the presentation. So this is it. This is for Venom. Click Run Analysis. Got the whole cast build and crew. We run through. We get our predicted score. Then we have our classification, clustering, and anomaly detection, which my group members are going to take you through. I'll take you through one more live example, which was another one that hit Ant-Man and Wasp, and we've got the main cast in there, and the director and writer. Came up with 7.2 predicted score. Go to IMDb, and predicted score was 7.2 out of 10 on 56,000 votes. So those match in that case. So that's all for regression, and I'll pass it along for classification.
Hi, I'm Raju Sharma, and I'm a graduate student in the physics department. In our project, I've been doing the classification part. For the classification, I've mainly been using the k-nearest neighbor classifier to classify the list of movies that we have into 4 different classes. The classes basically are excellent, which have rating 7.5 or above, average, which have rating 5 to 7.5, poor, which have rating 2.5 to 5, and terrible is anything less than 2.5. So k-nearest neighbor is a type of classification that is based on learning by analogy. So it classifies an unknown sample by searching the pattern space for the K training samples that are closest to the unknown sample. And it looks at the classes given to those K training sample, and then whichever class is repeated highest, it assigns that class to the unknown sample. So this is the code that I've been using for this one, and the dataset that I'm using is it looks like this. So it has title ID, average rating, number of votes, title type, start year, genre, and runtime minutes. So I input this file into the program, and then this program calls on the main.py program. So what this main.py does is it takes in the file and then does some pre-processing on it. So it basically removes any movies which have number of votes less than 50, because this kind of movies, the ratings are not that good, and these are really skewed. And additionally, it also removes any movies for which the runtime minutes are not given. And after it does that, then it converts the genre into from a list of string to a list of numbers. And once that is done, then it also provides classes for the movie based on the rating. So because we don't have, the dataset does not have rating given, the classes given from the start. And once it does that, it returns the file back to the classifier. So basically, once we get this file, then we ask the user how they want to split the file, into 80-20% or 90-10% or something like that. And we also ask them what is the number of K that they want to use for the nearest neighbor classifier. And since we have four classes, we suggest the user to use more than 4 K, which is more than 4 for the K-means classifier. Then once that is done, we split the data into training set and the testing set, and then we then go through the process of training the data set using the function written over here, and then after that we assign a class to the data, and then that is how we get and we later on calculate the prediction accuracy, which is basically how many movies we got correct out of the total data set that we test data that we use. So let's just run this program and let's see. So it asks for the percentage that you want to use from 0.0 to 0.9. So I'm going to choose 0.2. So this will 20% will be the test data for that one, and it asks for the number of K that I want to use. So let's try K as 11. It's better to use K as a odd number, because if it is an even number, sometimes we can get let's say if you choose K equals to 6, then we can get 3 Ks for 3 classes for 3 Ks, and then one class for 3 Ks, and then another class for 3 Ks. So there will be a tie, and then the result will not be good. So let's say 11. And once that is done, it goes through the data set, and then these are the testing data set, and it assigns. So this is showing the movie name, and then it's showing the genre of the movie, and then over here we can see what rating it's giving, what class it's assigning to the movies. So we see a lot of average, and we see a few excellent, and it takes a while to run. We see some poor as well. Alright, I will return once this is complete. All right, the program has finished running, and as we can see, like it has given all the prediction for the classes for all the movies we had in the test data set. And when we look at the accuracy, it's giving out about 65% accuracy for k equals to 11. If we change the k, the accuracy changes a little bit, but not that much. For k equals to 5, we get about 62% accuracy, so it's around that range. As k is as higher k is chosen, the amount of time required for that program to run increases, but not by much. So k equals to 11, it takes about 10 to 15 seconds for this data set with about 7,500 data points. So this is pretty good. And this is what we have. This is what I have for the k-means classifier. Another classification method that I have used is the naive Bayes classification. Naive Bayes is another method of classification that uses a version of the Bayes theorem, which is a mathematical formula for determining conditional probability, it uses that probability to classify the given instances. So basically, it looks at different probability of the different classes, and whichever probability is greatest, like it assigns that class to the test data. So this is the code that I've been using for the naive Bayes classification. This also makes use of the same main.py. I will hand this off to Sujin Sen, who has done the clustering part for our project. All right.
We did clustering analysis based on the most top-rated 270 movies. We hope to find some hidden patterns among the most successful movies. K-means clustering method is implemented here. We focused on using 19 genre features, including action, adventure, animation, and so on. Since these features are all categorical, we transform the data into the format that k-means can deal with. One hot encoding is used here. If the feature appears, its value will be recorded as 1. If not, its value will be 0. Therefore, we get a data table just like this in a binary form, and it contains 19 features for every movie. When running the clustering program, we can specify the minimum number of clusters. We can also specify the maximum number of clusters. Here we put it to be both 2 here. Then we get instances IDs of each cluster. This is the first cluster, and this is the second cluster. Next, we determined a reasonable value of the number of clusters k. The elbow knee method is used here. To get a robust result, we run the program for multiple times. Here we run it 5 times. Here is the result. As can be seen from the figure, each color represents one run of the program. Here we run it for 5 times. This is the sum of squared errors versus the number of k, and the optimal number is chosen to be 3. To conclude, the most top-rated 270 movies were clustered into 3 groups. Elements in one cluster is more similar than that in other clusters. The cluster result could be further improved by involving more features, like actors, budget, but that will incur high dimensionality problem, which needs to be using dimension reduction techniques.
Hello, my name is Aaron Holmes, and I will be talking about the anomaly detection part of our project. So just a little bit before I show you the actual code, for anomaly detection we've used relative density-based anomaly detection, and this is a little more advanced than just taking, for example, the distance to the fifth nearest neighbor, or just taking like 2 standard deviations away from the mean, that kind of thing. It's a little more complex than that, so hopefully it'll give us a little better values. The way this works is it creates kind of a small cluster around each point of the, for example, the 5 nearest neighbors to it, and then it computes, it sums up the distance between those points, and to come up with what's called a density. So it's kind of how big that cluster is, or how spread out it is, and then it compares that density for that point, that cluster, to the kind of average density, and that results in the outlier score, so you can tell how good or bad a point is. So here I'll walk through code real fast for you. Here's the distance function, is just Euclidean distance for the numeric values, and it's just kind of a equality for the factor values, so like strings and that kind of thing. And this function just makes a matrix of those, so it's just to speed up processing a little bit. That way we can just create a density matrix, and you won't have to compute the distance matrix. So that way you don't have to compute the distance between every point every time. You can just compute it all once, and then you're kind of done. So that's a little more efficient that way. This function here, all it does is just finds the nearest neighbors, so that's fairly simple. And here's the actual density function itself. It's related to the distance. As you can see, I'm passing the distance matrix, and then taking the nearest values. And then here's the average density function, which takes the densities for each point and creates, kind of spits out the outlier score that you're looking for. And finally, this last function here is just shows the kind of combination of all those functions. Here's you just getting the distance matrix. You're finding the nearest neighbors for each point. Here's where you call the density function, get the densities, and finally here's the average density function, and we're assigning that to the score. So you run that, and then we're saving it. This line here just runs it, and then these 3 lines here, I'm just saving it to the data frame, so it's so you can show it with the movie ID, so it's a little easier to read that way. And these are the biggest outliers, so you can see the different movie IDs. And as you can see, I only picked values bigger than 3, so we only have a few, so that's not bad. Most of the values were around 1, so I just printed off these several here to give you an example of what some of the bigger ones were. Like this one, for example, this movie has a really high score. This movie is slightly different, or slightly smaller, and most of these other ones are, they're a little out there, but it's not too bad. So that's pretty much all my function. We plan to apply these scores and remove the outliers that are pretty big for things like our clustering algorithm, which should make it more accurate, but we haven't quite gotten around to that yet. Finally, what we could do is we could take a look at some of these movies, like this biggest one here, and we can do things like if it has an unusually high score, then we could try and explain, so what's good about that movie? Why is it have such an unusual score? And vice versa, if it has a bad rating, then we can try and figure out, so what collection of things happen to make this bad.